So we'll use the elimination method for these guys. So we're going to change the directions here. So it should say solve the given system using the elimination method. So please make a note of that. I need an eraser. Solve the given system using the elimination method. And don't be surprised if we do these exact same examples in the next section. Oops. All right, let's begin. That's a huge line. There we go. All right, so step one. We only have 2 variables here, which is a little bit easier than 3 variables. We need to get rid of one of those variables. It does not matter which of the variables you eliminate first. However, ones that have coefficients of 1 or -1 are the easiest to go. So notice the x is easiest because it has a coefficient of 1. So let's use that to our advantage. If we had x's having a -3 and a +3, then when added together, what would happen to those x's? They cancel out. So what should we multiply the second equation by to make it a -3x? -3. So we're going to keep the first equation the same. And whatever you do to one side of an equation, you have to do to the other. So multiplying the second equation by -3, we would get -3x plus 15y equals -81. So multiplying an equation by a number, you're only changing what it looks like. You're not changing any of the values.
You say you get
-3 times 27.
Oh.
Is that okay?
Why did you choose the 39?
Sure. Because now notice when we add these equations together, what would happen to our x's? They cancel out. So step 1, multiply one or both equations by a number so that when added, a variable goes away. So if we add them together, one more time. Multiply one or both equations. So we didn't need to multiply both of them. If we chose to eliminate y, we would have to multiply the first one by 5 and the second one by 4. So now if we add these together, goodbye x. How many y's do we have? 19. And constants? 76. Okay. We do not need step 2 here because we did not start with 3 or more equations. And actually step 3 is sort of done because we're already down to 1 variable. So we can mosey right into step 4. Solve for the remaining variable. How would you solve for the remaining variable? We'll divide both sides by 19. What is -76 divided by 19? -4. Very good. Yes?
So you multiply whatever number you choose all across.
Yes, so we multiplied all 3 terms by -3.
Oh, okay, including the answer.
Including the number, yes. Whatever you do to one side, you have to do to the other. Yes. Yes. Well, now that we got y to be -4, we have to find the x. So you'd want to put -4 back into, in this case, you can go to the originals. Does it matter which of the 2 equations you use? No. How about we use the second one? So instead of x minus 5y equals 27, we'll have x minus 5 times -4 equals 27. What are we going to get for x? Seven, because this is x plus 20 equals 27. So subtract 20 from both sides. So what ordered pair did these two lines intersect at? 7, -4. Hooray! Yep.
Can you explain how you chose those equations for 5?
Sure. It doesn't matter which of the ones you start with to use. So if we use the 3x plus 4y equals 5, and we stuck in -4 in for y, we'll still get 7 for x. I picked...
You just used the 1.
Yes.
Okay, you just wrote it out the first time, and then you plug the y in. Oh.
Yes. Now, we technically should check our answer, and the way you would check is plugging this back into both equations, because what could happen is you find an answer that works for one but not the other. Typically that will happen is if you make a numerical mistake at this step. So go back through and check. I will show you how to check your answer on the calculator.
That should always match.
It should always match for all equations, correct. So if you have like 8 equations, but it works only for 7 of them, then it's not the answer.